Hello, in this video I'm going to cover section 6.3, Simple Interest from Contemporary Mathematics by OpenStax. The learning objectives for this video are to be able to compute simple interest, understand and compute future value using simple interest, compute simple interest loans with partial payments, and understand and compute present value. So when money is borrowed, the person borrowing the money, also called the borrower, typically has to pay the person or entity, so for example, like a bank, that lent the money, often called the lender, more than the amount of money that was borrowed. So if you're going to borrow, say, $1,000, you're not going to just pay back $1,000. You're going to pay back extra money on that $1,000, which is called interest. And that is to be paid in different ways, but in this particular section, we're going to talk about simple interest, which means that typically that is paid one time, but there are examples where simple interest can be paid more than once if you make a partial payment during the repayment instead of a lump sum at the end. So that is if you're borrowing money. This idea also applies if you deposit money into an investment type account, for example, a savings or something called a COD or certificate of deposit. And then that particular type of account is lending the money to the bank, and the bank is then paying that person back. So for example, if you give the bank $1,000 in a savings account, the bank is giving you money back in the terms of interest. And so both of those payments, whether it's you take out a loan or you give money to the bank and they pay you back interest, both of those sums of money are called the principal, P-A-L, and that's kind of the starting amount of the loan or the seed amount, the initial amount of the savings account. So interest to be paid by a borrower is often expressed as an annual percent rate, which we usually abbreviate and we'll see in financial terms as APR, annual percent rate. And this is always yearly. APR is always based on a year, and it means that and the more the interest is, either the more you're going to have to pay back or the more you're going to get paid depending on what type of account it is. Not only a higher interest rate gives you either more interest you have to pay back or more interest you're going to get paid, but also the length of time in which either the loan has to be paid off, which is called the term, or however long you keep the money in the savings account, which is still called the term, increases the amount of interest that you will receive. Now, another key term here, or key vocabulary, is what's called the origination date. Origination date. This is the first day in which the loan money was either given to you, or that you deposited the money. So it's just when the account started. So that's a lot of kind of vocabulary and overview in order to talk about what's really mathematically a very simple concept. No pun intended with simple interest. So simple interest is computed by this formula, I equals PRT, or principal times rate times time. Now what's important here is that time is always in years. So time is always calculated with years. And we're going to see why that's important when we talk about partial payments. And so the next formula would be the total repaid, which would be T equals P plus I, which is T equals total equals principal plus interest earned. And so another way to talk about that, if it's a loan, this is called the payoff amount. This is what you would have to pay off completely, including interest in the end. So let's look at a quick example. Calculate the simple interest to be paid on a loan with a principal amount of $4,000, an APR of 5.5%, and the term length of the loan is 4 years. So first over here, we'll calculate the interest. So we'll take 4,000. We're going to multiply it by the rate, which we convert to a decimal, and the time in years. So t equals 4. And so we have I equals PR times t is going to be 4,000 times 0.055 times 4, and that's $880. So the interest on a $4,000 loan at 5.5% APR for 4 years, that is going to be $880. So how much are we going to have to pay in order to pay off the loan? Because that's just the interest that was earned on the loan. So that's going to be $4,000 plus $880. So you're looking at $4,880 is going to be the payoff amount. So that is what you would end up owing in a simple interest example here for that $4,000 loan with those conditions. So when a loan is paid back after a term that's not, for example, an integer number, in other words, if it's not 1 year, 2 year, 3 year, what if it's 45 days or 60 days, 5 months, something like that? Then the time in years must be converted into a fraction. So for example, for a 5-month loan, we would convert that to 5 out of 12. Because again, T is always referenced in years. And so if it's a 5-month loan, then we're looking at 5 out of 12. Or an 18-month term, an 18-month loan, we would do 18 divided by 12, and we would get 1.5. So 18 months is 1.5 years, so we would use 1.5 as our T value. Now, if it's not a full year, we would calculate that out of 365 days. So that changes the interest formula where R is calculated out of, because again, it's APR, annual percent rate, we calculate that out of days. And that would divide the rate by 365. You can also think about dividing the time by 365. It doesn't matter where the 365 really goes in the formula. As you can see here in this second version of the formula, it doesn't matter if you're dividing the rate or you're dividing the time. The point is that you're dividing one or the other, not both, just one or the other, by 365 to make it in terms of days of the year. So let's look at this example. David plans to move his family from Raleigh, North Carolina to Tempe, Arizona, or I think that's how you say that, Tempe, Arizona. His company reimburses him, which means they pay him back after the move. He does some research and determined that the movers are going to cost $5,600 to move his family's belongings. He's going to take out a simple interest loan for 45 days at 11.75%. Now, I know that interest sounds pretty high, but that's really a low interest rate as far as like credit cards or something is concerned. If that was a car interest rate, yes, it's pretty high. If it's a mortgage, like for a house, that's extremely high. But for something like a credit card or like a 45-day loan, I know it sounds high, but it's really not. So let's look at how this is calculated. So because we're only going to consider 45 days out of the year, we are going to have to use that formula where we convert the interest rate, the APR, into days. So that's going to be P times R divided by 365 times T. And so here we've got 56,000 times 0.175 divided by 365. So that right there is converting it into 1 day, basically. This is a daily rate times 45 because there's 45 days. So that's telling us that we're going to be charged, or David's going to be charged $81.13 in interest. Now this is for the 45 days. Now in this case, we've rounded up because most financial institutions are going to round up regardless. And so we round this to 81.13. And so The payoff amount would have been the $5,600 plus the $81.13. And that gives us the $5,681.13. So that is, if we took out I would consider this sort of a short term, it's about a month and a half loan. That's pretty short in terms of loans. Still pretty high interest paid, but so what we've calculated in both of those examples is something called the future value. So that is the amount that the loan or the savings account will be worth, or we will have to pay back in the future. And so that is given by the exact same formula. It's just in finance terms, we call it the future value. You'll see it a lot of times abbreviated as capital F, capital V. FV is future value. So let's determine how much interest was earned on an investment and the future value of the investment, given that it was a $1,000 investment with an annual percent rate, an APR of 2.01%, and we left it in the account. We didn't touch it for 5 years. And so that's one of the big things about these savings accounts is that you can't touch the money. If you take anything out, it completely recalculates and kind of readjusts your future value. But let's take a look at this example. So we start with a principal amount of $1,000. Converting 2.01%, we just move the decimal place 2 to the left, and that gives us 0.0201 as our annual percent rate, and then our time is going to be for the 5 years. And so we calculate the interest by doing 1,000 times our rate times 5, which is our years. And so we're going to gain $100.50 in interest. So that is the interest earned. The future value is going to be the principal amount, which was the $1,000 investment, plus the interest we earned. And so we're just going to add those together. So that's going to be P plus I. So P plus I, and that's going to be 1,000 plus that $100.50. So that's going to be $1,100.50. So that's going to be our final answer for this problem. That's our future value. So in the example that we've given, in the loan case where David took out a loan, he paid it back as a lump sum at the very end. And that's not really how most loans go. In fact, most loans don't use this method of simple interest as far as one lump sum payment. They're extremely, extremely rare to find, if you will ever find one from a financial institution. Oftentimes what will happen is we'll talk about it in the next section. It's called compound interest, but you will make payments on it along the way. Well, let's look at what happens if you do that to a simple interest loan. This is called a partial payment. So if you're not going to pay everything off, including the interest, because if it's a loan, you have to pay off the full interest. But if you make a partial payment and only pay off part of the loan, what does that do to impact the interest? So let's take a look at an example. So we've got a simple interest loan for $6,500. It's taken out at an APR of 12.6%, and it's going to be a short-term loan. We're going to make a partial payment at the 45-day mark. Okay. What we want to do is calculate how much the partial payment would be. So what we're basically going to do is we're going to calculate the interest. So we're going to calculate the interest at the 45-day mark. And so that's how much the interest will be in the partial payment. So let's look at how that works. So again, like we did previously with David, where he only did the 45-day loan, we don't have a 45-day loan here. We have a longer loan. but we're going to make a payment at 45 days, which means that the bank is going to calculate how much interest we would have paid in 45 days. And that uses that daily interest calculation where we divide by 365. So to calculate the interest, we do 6,500 times the 12.6% divided by 365 times 45, and that gives us 100.9726, which will round up to 100.98. So the interest, let me go back for a second. The payment that we would make, a portion of that is actually going to be $100.98 worth of interest that we would pay at the 45-day mark. So if this was, a year loan or a 5-year loan, we would make a payment at 45 days, but that, $100 of that payment would go just towards interest, not completely reducing the balance of the loan. So let's look at this example. This is question 34 at the end of the chapter. Let's find the payoff value of the loan of a $21,500 loan. We've got a rate of 7.44% for 10 years, and we're going to make a $15,000 partial payment 6 years into the loan. Let's see what we would have. So the first thing we're going to do, and this is a little different, is we're going to calculate the interest at the 6-year mark, all right? Because that's when we're going to make our partial payment. So our original principal was $21,500 times 0.0744, and that was annually, and then we're going to multiply it by 6. Now, why have I not divided it by anything? Well, all of my terms here and the time that I made the partial payment is in years. It's not in days. And so I can just keep it in terms of 6 years. And so if I do $21,500 times 0.0744 times 6, then that's going to be $9,597.60. And that is just the interest that has accumulated on this simple interest loan after 6 years. So what's going to be the payoff amount? Well, that's going to equal kind of two things. It's going to be the balance after the partial payment plus the new interest. So that we're going to have to come back to that. So let me come back to that. All right. So the next thing we need to do is calculate how much is remaining on this loan after we've made a $15,000 payment. So the balance, sometimes you'll hear this as the forward balance because this is the balance going forward. It would be $21,500 minus the $15,000 that we paid plus the $9,597.60 in interest. So we started with a balance of $21,500. We paid $15,000, which takes away, and then we're adding back $9,597.60. So that's going to leave us with a forward balance of $16,097.60. So that is our forward balance. That's how much is left owing after we made our partial payment and was charged interest at the 6-year mark. So now our payoff balance that we have is going to be our balance, which is 16,097.60 plus the new interest for the remaining 4 years of the loan. So, and that's going to be on the 16,097.60, It's the same rate, so 0.0744 times, and then we've got 4 years left because we made the partial payment at the 6-year mark. We still have 4 months left to pay. So 16097.60 times 0.0744 times 4. So that's going to be $4,790.65. And so we're going to add that to our 16097.60. And so at the end, we are going to owe $20,888.25. So that's quite a bit, right? I mean, we paid $15,000 and we still owe $20,000. You're like, whoa, why do we still owe so much? Two major reasons why. First one is we had a rate of 7.4%. That's a pretty high interest rate. And second, we paid on this for 10 years, like a decade of paying on it. We also had a large principal amount to begin with. So, kind of as a precautionary tale about this is these are all very good numbers for when you go buy a new car or even a really nice used car is about 21.5. Now, cars are not compounded simply. They do not charge interest simply. They also they don't do a one-time kind of in the middle payment and then you pay off at the end. But it does give you a good idea that the higher your interest rate, the higher your principal, and the longer you take to pay it off, the more expensive in general it's going to be. And so as like I said, as a precautionary tale, car loans nowadays have a rate of about, so cars have a rate of about anywhere from 5 to 7%. They can be as high as 11%. And then car loan terms are usually 7 to 10 years. So, even your new Tesla, Tesla will do loans for 10 years. And one of the reasons that is the longer you make the term, the less the car payment is. But you end up paying more in the end. But there's a whole section on cars we'll talk about later. So there's also this concept of repeated partial payments, which is really what we do. Car loans, mortgages, these are paid monthly. They're repeated. It has a fairly complicated formula that is presented here in the book. And for this section, I'm going to talk about it. But in the next few sections, I'm going to introduce you to some technology that takes care of this. And you don't have to memorize this formula. So please don't get freaked out by this formula. Please don't try and memorize it. Just kind of look at it and say, yeah, that's complicated, but it's doing some complicated math. We're making repeated partial payments, for example, monthly, so forth and so on. So for this particular one, the amount of monthly payments A, so A is, how much is the payment going to be? P is the principal and R is the rate. And then you've got this 1 plus R to the T, which is the number of months. That's different in this, so you got to be careful with that. This is the number of months, and the monthly interest rate is the annual rate, so that APR divided by 12. And so this is the exact formula that you would use to kind of figure out your car payment if you were going to make a car payment on something. So let's look at an example of that. So Desiree buys a new car, taking out a loan from her credit union. The balance of her loan is $27,845. She gets a 7.3% interest, and she's going to pay over it for 4 years. How much would her monthly payment be? So I'm just going to write out, we've got P equals 27,845. R is going to be 7.3%. which we're going to convert to 0.073. And T is going to be 4 times 12, because remember, we're talking about monthly. So that's going to be 48 months. So using all of that information, we're going to plug that into our formula, which I'm highlighting here on the screen. So we're going to plug it into the formula. And so that's going to be 47. Oh, that should be 27, not 47. That's a typo from the textbook. So 27,845 times 0.0683. Now remember, that is because we divide this rate by 12. And so that's going to be 0.006083. And so one thing the book is doing here that they don't really talk about is they're using four numbers, the 6083, to kind of represent this number. Instead of chopping off decimals, we want to keep basically those 6 decimal places. And that's just so that the math works out. And so that's the same in those 3 places. That's our R. And then our T, which was 48 because it's 48 months. And then if we type that into the calculator correctly, we do end up getting $670.67. So that gives you an idea of how much, if you buy a $27,000 car, or let's call it $28,000, you're going to be paying about $680 a month in a car payment. And that's actually pretty close to the correct answer for today's, in the real world. If you went out and bought a car today, what you should pretty much expect to pay, the national average of a car payment's over $700 now. So let's go back to talking about future value. We know how much is deposited, but maybe we don't know how much money it will be worth in the future, right? We know we deposited $1,000. How would we find out? Basically, let's say, for example, you wanted to have $2,000 to go on a trip and you wanted to save this money. How could you roughly estimate how much you need to put into an account today in order to have $2,000 in the future? And so that amount that you would need today, we call the present value, or PV, capital P, capital V, and that is calculated kind of we call it a back of the envelope calculation. It's not exact. We'll talk about more exact answers in later sections in this chapter, but a sort of a back of the envelope calculation would take the future value and divide it by 1 plus the rate times time, where again, R is the APR of the account and T is the years. And so this would tell you kind of how much you need to deposit today in order to have that much in the future. So let's compute the present value of an investment that is $10,000 in the future. So in other words, we want to save $10,000. We've got 15 years to save it, and we're getting a 5.5% interest rate. And so everything's kind of laid out for us here, already nice and kind of written out. So we've got PV equals the future value divided by 1 plus RT. So our future value is $10,000. That's how much we want to have in the future. And then we've got 1 plus, and we convert that rate to a decimal, so 0.055 times 15. And so if we simplify that, that's going to be 10,000 divided by 1.825, and that gives us 5,479.4, we'll say 6. And so what this means is, if we want $10,000 in 15 years, based on what we're given here, then we need to put into the account today $5,479.46. All right, and if you can put in basically $5,500, you're doing even better. But in order to get what you want for this account, you would need to deposit about $5,500 in order to save $10,000 15 years in the future. Now again, this is assuming simple interest, okay? We'll talk about not simple interest or compound interest in the next section. But that's all I have for you in this video. Of course, there's a lot more examples and worked out, there's more worked out examples in your textbook. So you've watched the video. I hope you've taken some written notes. If you haven't done so, go over and read the textbook. They've got lots, like I said, great examples. But what's really important there are the your turn, you try problems with the answers at the end so you can test yourself and know whether or not you're getting this information. And then finally, once you're done with all of that, head on over to the LMS and work on the online homework there.